All right, so we are going to start talking about how to do this problem right here, quadratic formula. So you can read that just as well as I can, but we're going to be using the quadratic formula basically to solve a quadratic in standard form here. So ax squared plus bx plus c. We're going to write a program that accepts the coefficients a, b, and c. If those values would result in imaginary results, in other words, if the radicand, or maybe you've heard that called the determinant, is negative, we should tell them that there are imaginary results. Otherwise, your program should state that and give no further output. So say like it's going to be imaginary results. Otherwise, the program should display the two solutions. You don't have to worry about the case where you have identical solutions. So if you know a little bit about algebra, or maybe more than a little bit of algebra, then you know that this b squared minus 4ac sometimes is called the determinant, and it can determine whether we have no real roots, one real root, or two real roots, and so we could work that into our solution. Okay, so we're going to start off by creating a new class called quadratic formula. And we want that to have a main method. So I'm just going to clean this up a little bit here. So the first thing that we're going to do here is create a scanner for input. So system.in is the thing that we're going to be scanning. All right. And then we're going to prompt with system.out.print to enter A. And after they enter A, or we're going to allow them to enter A into a double called A. And so we're going to go input.nextDouble. Okay, so when I did that, it automatically imported scanner for me. It added this import java.util.scanner up here. If it didn't do that for you, you can either mouse over scanner or you can just type in the import statement up here. Okay, so then the next thing we're going to do is copy that and paste it 2 times. And then we want them to also enter B and C. All right. So we've done kind of part of the problem already, and if we go back to the problem descriptor here, we can see that we're supposed to check to see if the values would result in imaginary results, which it happens when the radicand or the determinant is negative. So let's go ahead and create another double variable. And are you guys better off with the word determinant than radicand? Okay, so let's go ahead and say the determinant. And the determinant is going to come from b squared minus 4ac. So the easy way to do b squared is just b times b, and that's actually probably the better way of doing it. Okay, but just to kind of maybe review some stuff here, we'll say that we're going to do the math.pow method. So that's the way that we can find a power, and we want to find b to the second power is basically what we're saying right there. And then we want to subtract 4 times a times c. Okay? So again, this is b squared minus 4ac. And then we want to determine whether that's going to give us imaginary results. Okay? So basically what we could say is if the determinant is greater than or equal to 0, then we're going to do some math. Else, we're just going to print out that the values they gave us would result in imaginary results, or imaginary roots. Okay, so I'm kind of assuming that you understand some of that math, and if you don't, then I'll spend some time in talking about it a little bit later here. But so for right now, we're just saying if the determinant is not greater than or equal to 0, that means it must be negative, and then the values result in imaginary roots in that case. Okay? If they don't result in imaginary results, then we can go ahead and use the determinant to determine what those roots are. Okay? So we could say like double root 1 equals, and then we could say the opposite of b plus the square root, so math.sqrt, of the determinant, okay? And I want to divide all of this by 2a. So I'm going to group that with parentheses, okay? And this is also an important step here. If we do 2 times a here, okay, we're actually going to get the wrong result. Okay, so this is grouping this whole numerator, but division really has no more precedence than multiplication. Okay, so when we do this, when we group this, this will give us one result. That result will get divided by 2. It'll find that answer, and then take that answer and multiply it by a, which is really not what we want. We really want to divide by 2a, so we have to group that together as well. Okay? So that would be root 1. Root 2 is going to be basically the same thing, except that we're going to put a minus sign here, because that's how the quadratic formula works. We do opposite of b plus, and then opposite of b minus. So root 2 is the same thing with a minus sign there. And then we're just going to report those roots. So print line, and we could say root 1 equals root 1. Root 2 equals root 2. Okay? One thing that I always forget to do, and I'm not forgetting it today, which is incredible being that it's a Monday, is that when we create a scanner object, we always want to close that scanner at the end. So input dot close when you're all done scanning stuff. Okay? So basically a scanner is a stream to some data, and we want to close that stream off. Okay? So that's the idea behind that. And if we run this thing, so it's easy to come up with values that result in imaginary results. So like 2, 5, 7 should be imaginary. So the values result in imaginary results. Okay? If I make this a negative 2, then I should get actual roots. Okay? So if I run this again, negative 2, 5, 7, then I get the roots negative 1 and 3.5. So that seems like that's working. Okay, we can talk about the math behind that if you're confused a little bit later here. But that's the idea about like the kinds of problems that we're going to encounter here. Okay.